Bismillahirrahmanirrahim. Assalamu alaikum viewers. You're watching YouTube and Facebook channels of Professor Dr. Rizwan Jamil Qureshi, and I'm covering software economics course lecture number 11. So we discussed project specs and I covered the project introduction, and then we are covering cost estimation techniques, and we covered line of code method, which depends on the history of previous projects, and it's not accurate estimation method to quote the customer, and it doesn't deal with the complexity. And another problem is that it's language dependent method. So because of that, the problems of line of code method force the researchers to introduce a new cost estimation technique, and they introduce function point. The function point deals with functionality of the current project, and it has a formula UFC multiplied by TCF. UFC stands for unadjustable function count, and TCF stands for technical complexity factor. So how to calculate unadjustable function count? As I discussed in the last lecture, it has 5 parameters. So we have number of external inputs, number of external outputs, number of inquiries, number of logical files, and number of interfaces. You have to input the variables for optimistic, realistic, and pessimistic, best case, average case, and the worst case. And then you have a formula to calculate EC, average count, O plus 4 into R plus P divided by 6. So optimistic, 1 value, realistic, 4 value, and pessimistic, 1 value. So 1 plus 4, 5, 5 plus 1, 6, 6 divided by 6. So it's average formula. And then you have complexity factor, that according to the type of project, we have simple complexity, we have average complexity, and we have high complexity. So simple complexity project, average complexity project, and high complexity project. So for simple complexity, we have constant available in the function point method. For inputs, for the simple project, it's 3. For average project, it's 4. For high complexity project, it's 6. So in case of simple, you will select only the simple. You multiply EC with the simple complexity, and you ignore average and high complexity. In case of user outputs, so again you have simple complexity 4, average complexity 5, high complexity 7. In case of inquiries, you have simple complexity 3, you have average complexity 4, 5. In case of high complexity 7. In case of inquiries, 3, 4, 6. In case of files, 7, 10, 15. Number of logical files are actually your number of tables, because in 1980s we have file-based systems. So now we have databases. So instead of files, we use database tables. So we need number of tables. Number of interfaces, you have 5, 7, and 10. As I just mentioned, you will select only the specific complexity. So for simple complexity project, only the simple. If it is average, you will select only 7. In case of high, you will select only high complexity. So you ignore simple and you will ignore average. These numbers are constant and will be available to you in exam. No, it will not change. Only the variables will change for optimistic, realistic, and pessimistic according to the nature of project, according to the requirements, according to the system to system. It will vary, or it may vary from expert to expert. So for example, I am the project manager or I am the system analyst. So for inputs, I may assume for optimistic 32, for realistic 15, for pessimistic 5. But for example, Muhammad Khamis, you are the project manager. So you say no. According to my experience, the optimistic is 40, realistic is 20, and pessimistic is 10. So project manager to project manager or requirements to requirements, these values will change for optimistic, realistic and pessimistic, but not for constant. So only you will select according to the nature of project. If it is simple complexity, you will select only simple complexity. If it is average, you will select only average. If it is high, you will select only high. Whatever the complexity, for example, most of the projects are average complexity. Some previous code you have and some new code you have to write from the scratch line 1. So for example, it is average complexity project. So whatever the EC value you have after doing the calculation of optimistic plus 4 into realistic plus P, the pessimistic, divided by 6, you have EC. So you have for inputs, you have EC value. For outputs, you have EC value. You have inquiries, you have EC value. Number of files, you have EC value. Number of interfaces, you have EC value. So you have 5 EC values for 5 parameters. So you multiply the EC value with the complexity factor, then you have 5 values in front of the last column. Summation of these 5 values is equal to UFC. UFC is equal to sigma summation of these 5 values that you have after multiplying the EC with the complexity factor. For TCF, you have a formula, technical complexity factor 0.65 plus 0.01 multiplied by sigma Fi, and sigma Fi is equal to 1 to 14. So F1 to F14, there are 14 questions you need to grade between 0 to 5. 0 means it's not applicable and 5 means must. You must need to consider, and you will sum them. The summation of the 14 question values between 0 to 5 is equal to sigma Fi. For example, these are 14 questions. These are 14 questions. Does the system require reliable backup and recovery? Now, if it is banking system, then you will assign 4 or 5, because bank normally have 3 to 4 times backups per day, because it's a matter of transaction money. But if it is attendance system, you may have backup after 15 days or 1 month, because it's not damaging. So you may assign 2 or 3 or 1, for example. Is performance critical? So for example, if it is safety critical project where human life risks are involved, like for example flight control system, nuclear reactor control system, fire alarming system, space shuttle system, then you will assign 4 or 5. Or for example, for hospitals, Mustashfa Nizam, you have robotics, AI, artificial intelligence, surgery of human brain, eyes, heart, liver, kidney. So it's a matter of human life. So you are using robotics for operations, for surgery of patients. Then you need performance very high, critical. It's critical, like 99.999% you need accuracy. Then you need 5 or 4. But for attendance system, inventory system, you may have 2 or 3. So in this way, you have 14 questions. You will answer each question, you will scale between 0 to 5. And summation of these 14 questions is equal to sigma Fi. So you will put sigma Fi value. Normally, whatever the case studies I found during my career, the sigma Fi value ranges between 49 to 55, and it will also be available to you in the exam, because you are not very experienced and it's difficult for you to grade. So in order to do calculation for course, I will give you sigma Fi value in the exercise and in the exam. So don't worry about that. So you have to put sigma Fi value, like for example, it is 49 or 50. 50 multiplied by 0.01 plus 0.65, so you have TCF value. So you have now UFC value, you have TCF value. So UFC multiplied by TCF is equal to function point. That means total number of functions you need to develop for the new project. Now let's go to the exercise. This is exercise number 1. So number of inputs, number of outputs, number of inquiries, number of files, number of interfaces. So optimistic value, realistic value, pessimistic value are given. So you have to calculate EC. So draw a table, 7 rows, 7 columns. Yes, 7 rows, 7 columns. Like in this way. Now, you put the value. So in case of inputs, 18, 22, 28. And then you have EC. And then you have complexity factor. So last column, keep it empty. Realistic, multiply by 4. And then you add with optimistic. Then you add with pessimistic and divide by 6. So I intentionally put double bracket to make it clear for you. Now, you calculate EC for number of inputs and then multiply with the complexity factor. So you have value in front of input 89.34. Everybody has the same? Okay. Calculate number of outputs, EC for outputs, and multiply with the complexity factor. So 17 multiplied by 4 plus 14 plus 24 divided by 6. Now, for the students who have completed, multiply with the complexity factor. And like this table, like for input, put it in the last column. You have 5 values here in the last column. Summation of these 5 values is equal to UFC. Calculate the summation of these 5 values in the last column. That is equal to UFC. The summation of 5 values is equal to UFC. So it's approximately 349. So 348.6 mean approximately 349. This pet question in mid and the final from the function point. And it's a lifetime learning. UFC is unadjustable function count, which is depending on 5 parameters. Number of inputs, external outputs, external inquiries, number of logical files, number of interfaces. So from the requirements, you will approximately calculate values for inputs, optimistic value, realistic value, pessimistic value. Then for outputs, then for inquiries, then for files, number of interfaces. Because you have done communication with the customer and you collected some initial requirements, so you can prepare your feasibility. You can prepare your project specs to submit to the customer that what will be the benefits and what will be the cost of project. So in order to calculate cost, function point method is very effective because it directly deals with the complexity of the new project and it directly deals with the functionality of the new project. So from these 5 parameters, you will calculate EC, and realistic is the most average count. So you will give it 4 weightage. So O plus 4 into R plus P divided by 6, you will calculate EC, estimated count. Now you know your project is simple complexity or average complexity or high complexity. Like for this case study, it's average complexity. So complexity factors are given for inputs, outputs, inquiries, files, interfaces. So we multiply EC with the complexity factor. So you have 5 values. Summation of the 5 values equal to unadjustable function count. Project manager will give you values. He has experience. From the requirements, he will tell you that these are the optimistic value, realistic value, pessimistic value for inputs, for outputs, for inquiries, for files, for interfaces. Then you will apply estimated count, average count formula, O plus 4 into R plus P divided by 6. Then complexity factors are given according to the nature of project, that it's a low complexity project, average complexity project or high complexity project. Like I will go to the complexity factor. So according to the complexity, you will select the complexity factor. Like for this exercise, what we are doing, its average complexity. So we have average complexity. So multiply EC with the complexity factor. So you have 5 values in the last column. Summation of these 5 values is equal to UFC unadjustable function count. Now we will go to the technical complexity factor. Technical complexity factor is this formula: 0.65 plus 0.01 multiplied by sigma fi. Sigma fi value for this exercise is 50. So apply in the formula and calculate TCF. Summation of 14 questions value is 50, that we scale between 0 to 5. So again, project manager will give you sigma fi value and you will calculate TCF, technical complexity factor. 0.65 plus 0.01 multiplied by sigma fi equal to 1 to 14, the 14 questions I showed you. Function point formula is fp is equal to uf multiplied by TCF. So you calculated UFC, now you multiply with TCF, you have function point. Calculate. So UFC is 349 and TCF is 1.15. So UFC value is approximately 349 and TCF is 1.15. So 349 multiplied by 1.15. So FP function point is equal to approximately 401. What does it mean? It means in the new project you have to develop 401 functions. Function point means 401, we calculate 401. That means approximately 401 functions in the new project we need to develop. That is indication of function point. So we calculated function point for exercise 1 in today's lecture. Inshallah, we will continue function point in the next lecture to calculate the project cost, because we need to calculate project cost. So we have calculated number of functions. Now we will calculate inshallah project cost in the next lecture. Thank you very much. Jazakallah khair. May Allah bless you. Assalamu alaikum. See you inshallah in the next lecture. Have a nice weekend and holiday. Love you.